Hey everybody, this is Fred G. Sanford. The G stands for great. This pre-calculus lesson is on solving systems of linear inequalities. Let's go ahead and do the board problem. And I called this 10B because I just inserted this lesson in between some others here. So anyways, find the value of the determinant. Okay, first you got to add those two columns, these columns, this one and this one, right next to that right here. And then we go diagonal. We're going to go 25 times negative 12 times 9. And then these three numbers multiplied, and then these three numbers multiplied. We're going to do that first. That's right here. Okay, and then we subtract and go the other way. Okay, and then I cranked all those out, and it comes out to negative 3,183. All right, so here we go. Solving systems of linear inequalities. Okay, this is the vertex theorem. And what it says is if you're given a function in terms of x and y, then on any polygon that's going to be bounded by some equations, then your maximum or minimum will be wherever the vertices are where these bounded by equations are. And I think that'll make a lot more sense with this example right here. So here we are, we have this function in terms of x and y, x minus y plus 2, and we want to find the max or minimum values of the polygon that's bounded by this inequality and this inequality and this inequality and this inequality. Okay, in the last chapter, I showed you how to graph systems of linear inequalities. So go ahead and take a look at that if you don't remember how to do that, and I'll just briefly go over it. So first, on this one, I just solved for y on each one of these equations just for graphing purposes right here. So I subtracted x on both sides and divided by 4. Here I subtracted 3x and divided by negative 2 and I flipped the inequality. Here I subtracted x. Here I subtracted 3 and divided by negative 1. And it flipped the inequality. So here it is right there. And then I graphed all of those right there. Okay, so you can see this plus 3 is right here, and then you go use the slope down 1 to the right 4. There's that one right there. This plus 3 is right here, and then I would go up 3, 1, 2, 3, and then to the right 2. That's this one right here. Okay, and then down to negative 2 is right here, and then use the slope, negative 1 over 1, so it went down 1 to the right 1. That's this equation right here. And then the other equation comes from that one right there. So it's bounded by this region right here. So I'm interested in these vertices. This one's at negative 2, 0. This vertices at 0, 3. This vertices at 4, 2. And then 2, negative 4. And I'm interested in those vertices because now I'm going to plug all those vertices in my function f of xy equals x minus 2y, x minus y plus 2. Okay, so let's plug them all in. And so I plugged them all in, all those vertices right there into that, and now I can see which one has the max, okay? So the max is here at 8, and the minimum, the smallest number, is at negative 1, okay? And the vertex theorem ensures that that's how we can find our max and our min given these circumstances. So my max is 8 at 2, negative 4, and the min is negative 1 at 0, 3. All right, never fear, I got another one for you. Same problem, but different function up here, and it's going to be bounded by these equations right here. So I'm going to go step by step, and let's graph x is greater than or equal to negative 1. Okay, now greater than or equal to means it's going to be shaded to the right. Okay, and I put an arrow there because I don't want to shade it yet. Okay, now we're going to graph this one. Y is in between 2 and 8. Okay, Y is a horizontal line right here and right here. So in between 2 and 8. Okay, it's going to be in between those two guys. So far, it's somewhere over here because it's to the right of this vertical line. Okay, let's graph this one. Okay, I did my zeros, my intercepts, you guys. So I did 5, 0, and 0, 5. Here's 0, 5, and here's 5, 0. Okay, and then I shaded that side. Okay, so now I know it's somewhere over here. Okay, now let's graph this guy. Okay, there's that guy, and plus 14, I had to extend my y-axis way up there to plus 14 and then graph it. So now I know it's in this little region right here. So there's my shaded region right there. I need all those vertices right there. Whoops, all those vertices right there. So now I'm going to plug in each of those vertices into my function to find my maximum and my minimum. And I did that all at once. You can pause it, you guys. You can always pause it, but I've done that already. And my max is 11 at 1 comma 8, and my min is negative 5 at 6 comma 2. Okay, and if you're in my class, that would be your homework assignment.